For years, astronomers have been watching one of the brightest and most mysterious stars in the night sky, Betelgeuse, a red supergiant teetering on the edge of collapse. Scientists knew it was coming. They just didn't know when. Now, thanks to the James Webb Space Telescope, we've witnessed something once thought impossible the moment Betelgeuse began to explode. A stellar death, a cosmic shockwave, a breathtaking window into the raw power of the universe. This isn't just another deep space discovery. This is a once-in-a-lifetime event, the closest supernova humanity has ever recorded. And what Webb has captured has changed everything we thought we knew. Betelgeuse, perched on the shoulder of the Orion constellation, is no ordinary star. It's a red supergiant over 700 times the size of our Sun and roughly 20 times as massive. For decades, scientists have tracked its instability, swelling, dimming, erupting. In 2019, it suddenly faded, igniting global speculation. Was this it? Was Betelgeuse finally going supernova? Now, with the unprecedented clarity of the Webb Telescope, the mystery has only deepened. For the first time, we're witnessing in real time the signs of stellar collapse, massive energy discharges, shifting surface convection, and magnetic fields spiraling into chaos. Betelgeuse isn't just dying. It's transforming before our very eyes. The James Webb Space Telescope has kept its focus on Betelgeuse for months, using its infrared eyes to peer into layers that no other observatory has ever seen. And now, the data is in. What it reveals is nothing short of extraordinary. Convective bubbles the size of Jupiter erupt across its surface. Plumes of searing gas stream outward at unimaginable speeds. Buried in the light spectrum, a distinct shock wave pulses through the star's outer layers. This isn't a simulation. This is the real-time anatomy of a supernova, unfolding just 642 light-years from Earth. Unlike supernovae that blaze in distant galaxies, Betelgeuse is close. In cosmic terms, it's practically in our backyard. Its explosion could eventually shine so bright that it becomes visible, even during the day, brighter than a full moon. But its nearness offers something even more valuable, a rare, perhaps once in a generation, opportunity to study a star's death up close. How its core collapses, how heavy elements like carbon and oxygen are forged, how the shockwave reshapes the surrounding cosmos. What Webb has captured isn't just a star dying, it's the very process that creates the ingredients for life. The same elements that formed Earth, our atmosphere, and even us. In watching Betelgeuse collapse, we are witnessing our cosmic ancestry in reverse. The explosion of Betelgeuse is more than a spectacle. It's a key to unlocking the hidden processes behind galaxy formation, planetary systems, and the cycle of life across the universe. With Webb's advanced instruments, scientists can now model the final stages of stellar evolution with unparalleled precision. For the first time, we're beginning to understand the true mechanics of how a star ends and what to look for in others. This isn't just science, it's revelation. A moment where humanity peered into the abyss of time and saw the light explode back, but the drama doesn't end with the explosion. Betelgeuse's death is sending shockwaves across space, disturbing the interstellar medium for light years around. Webb has already detected high-energy particles racing outward, heating nearby gas clouds and distorting the star's surrounding dust halo. Even more intriguing, a possible gravitational shift. The collapse of Betelgeuse's core may have emitted gravitational waves ripples in spacetime we're only just beginning to detect. If confirmed, this would mark the first time a visible supernova has been directly linked to gravitational wave data, potentially rewriting our understanding of how light, matter, and spacetime interact. And then there's the ultimate cosmic question. What's left behind? A neutron star? A black hole? Or something even stranger? The latest Webb data hints at irregularities, magnetic field disruptions, plasma voids, and signs of asymmetric fallback, where matter is pulled inward instead of being expelled. Some astrophysicists are now speculating about a transitional object, a theoretical phenomenon that lies somewhere between a neutron star and a black hole, long hypothesized but never observed. If Webb has truly captured one in the making, it would be the first direct evidence of a new class of cosmic object. Naturally, people are asking, are we in danger? The short answer is no. Betelgeuse is far enough away that its explosion won't harm Earth. But the longer answer is more nuanced. The supernova will unleash waves of gamma radiation and high-energy particles, which could ripple through our galactic neighborhood, disrupting cosmic dust clouds and altering how light from other regions reaches us. Even though we're safe, the explosion could permanently change the way we observe the universe from Earth. Webb is closely monitoring the radiation's velocity and spread as we speak. Betelgeuse is massive, ancient, and powerful, but now it's dying. And in its death, it offers us a profound reflection. Even stars, the eternal lights in our night sky, have limits. What Webb has captured is more than just the end of a star. It's a cosmic mirror held up to us. Everything that lives eventually ends, but in those endings, new beginnings are born. New elements, new stars, new worlds. This is not destruction. This is cosmic renewal, and we are the lucky witnesses. Among the wealth of data gathered by Webb, scientists discovered something unexpected: unusual variations in the elemental composition of Betelgeuse's ejected material. Alongside carbon, oxygen, and iron, rare elements like technetium and yttrium were detected, substances forged only in the most extreme stellar environments. This discovery matters deeply. By analyzing the ratios of these rare elements, scientists can trace the life cycle of matter in the galaxy, from the cores of dying stars to the dust that forms planets, to the atoms inside every human being. Webb isn't just recording an explosion. It's decoding the chemical script of how life itself becomes possible. And in its final moments, Betelgeuse is telling a story that began long before Earth ever existed. Betelgeuse will never return. Its brilliant presence in Orion will fade, replaced by an expanding cloud of superheated gas and glowing debris. But its death isn't an end. It's a gift of knowledge, of elemental legacy, of cosmic perspective. It reminds us that our own sun will one day face a similar fate. Even the brightest lights have a final act. And yet, from that final act comes the blueprint for everything new. Without supernova, there are no planets, no oceans, no life. And now, thanks to the James Webb Space Telescope, we are finally able to witness that full cycle from fiery collapse to the raw materials of creation. In the cold silence of space, 642 light years from Earth, a star ended its life. Not with a whisper, but with a brilliant roar that traveled through the darkness for centuries until it reached us. Thanks to Webb, we didn't just see it, we understood it. We saw the signs, the collapse, the detonation, not as myth, not as metaphor, but as fact. Betelgeuse didn't die in vain. In its final breath, it gave us answers to questions older than humanity itself. Where do the elements come from? How do stars live and die? And what will become of our own sun? In that fading red light, Webb has captured more than a supernova. It has captured our origin story and a glimpse of our future. So now we ask, what else is the universe ready to show us? And are we truly prepared to witness it?